Yes, children. Myself, Yashoda. In the last videos, we'll try to understand human eye and the colorful world. Part 1, we understand, right? In the part 1 of human eye and the colorful world, we discussed regarding the eye, what is human eye, how it will going to work, functions of and parts of each and every part of the eye, okay, like cornea, corona, and earlier inner layer of the eye, everything we discussed, and the function of each part of the eye we discussed, okay, how it will function. And now coming to the main important thing regarding the eye is the power of accommodation. What is this accommodation? Means we want to see one nearby object and far object at a time. So that time what happens? Focal length of the, okay, suppose we have the lens which is outside, that suppose you fix with the lens stand, what will happen? You want to see the, suppose some tree is there here, you want to see this tree, you're going to put the screen here so that rays will come from the tree and it will going to form the image there. It will converge and form image. That means when you adjust correctly, that is the object distance and image distance, you will get the image at that place. That means the focal length of this lens is 10, means you will get a distance image at 410 centimeter. We cannot change this. Always you will get the image at only 10 meters only. That means when an object is at exactly 10 centimeter, image will get at this distance. Suppose our human eye, okay, we cannot adjust, we cannot change its distance in front or far object. Like this lens, we can going to adjust the distance so that we'll get the image on the screen. But this lens, we cannot adjust. It is the retina distance from, okay, distance from the mirror, what is the lens and the retina, that is the screen. It is fixed here, the screen and the lens, we're going to change it whatever distance we want. But here we cannot change it. Okay, that means it is always fixed. In that condition, we cannot change image distance or object distance. In that condition, what we can change? We can able to change the focal length by increasing the size, that means thickness of the lens, or by decreasing the thickness of the lens, we're going to adjust the focal length. That means by when focal length is adjusted, we can able to see near object as well as a far object. Wherever the distance is there, we can able to see it clearly. That is what we call power of the adjusting the focal length. That is what we call power of accommodation. Okay, let us see now. Yeah, what is power of accommodation? Means the ability of the eye lens to adjust its focal length. That is what we call focal length. You want to see near object, the focal length, the small, the thinner, and you want to see far object, the focal length is thin. That means the lens thickness. Okay, if thickness is less, it is more length like this, that time focal length is more. When thickness is more, length is less, that time focal length will be less. So based on that focal length is less, means we can see nearby object and we can see the far objects clearly. So like that, our lens, the using the ciliary muscle, it will going to adjust this. That is what we call power of accommodation. Yeah, you can see the picture here clearly. Power of accommodation, you can see near objects and the far object. Both you can see clearly, right? Children, the near object also you can identify man is there, and far object also you can identify dog is there here. That means by seeing the object we can identify. That means clear image we are going to get on the screen. That nearby object image also get on the screen clearly. Far object also get on the retina clear image. That is possible by adjusting our eye. I have the power to adjust its focal length. But normal lens means we can only focus at a time the near object or at a time to far object. Only one we can adjust using the lens, ordinary lens, which is made up of glass outside. But our human eye has the power to adjust it, whatever the distance object. All these distances it going to adjust it by seeing the, by adjusting focal length. That is what we call power of accommodation. The ability of a human eye to focus the objects lying at a different distances. That is what we call as a power of accommodation. I hope this is clear, children, what is power of accommodation. Now see what is the near point of human eye and the far point of the human eye. So near point means we can able to say up to what extent. Suppose you have one book, okay, up to what distance you want to keep closer so that we are going to see that. That is what we call the near point. And far point means up to what extent we are going to identify there is a images there. So near point of human eye is 25 centimeter, and the far point up to what distance we can see. Okay, we can see up to, we can see more distance. That is what we call infinite. So for normal eye, the near point is 25 and the far point is infinity. That means suppose your eye to any object distance is less than 25, like 24, 23 or 30, 10 centimeter, we cannot able to detect which object it is, because our human eye has capacity that what 25 meters away from our eye we can able to detect that object. That is what we call near point of the eye. And the far point of eye means up to infinity we're going to identify whatever the object is there here up to infinity we're going to identify that object. So that is what we define. Near point means the least distance of a distinct vision of the is the point of nearest to the eye, which is the object is visibly distinctly. We can visible distinctly. That means suppose here we can see, but we cannot see distinguish how many objects are there. Suppose here two balls are there. We cannot distinguish it is less than 25 centimeter. We cannot distinguish them. There two are present. If it is more than 25 is there, then only we can distinguish the two balls are there. Or else we can combinedly make one ball we can view. Okay, here also up to infinite we can. Far point of eye is a minimum distance maximum. This is a minimum distance and this is a maximum distance up to which the normal eye can see the clearly. It is the infinity for the normal eye. So understand, this is infinity for normal eye, only the normal eye. That means you are a healthy person. For any defective eye is there, this is not infinity. Only at one particular distance we can see blur image. That time we can correct using some kind of lenses we wear, no? The spectacles we are wearing, so correct this vision point only. So this is what near point and far point of the normal eye. For normal eye, near point is 25. For normal eye, far point is infinity. For defective eye, the far point and near point going to vary according to their lens defection. Okay, I think this is clear, near point and far point. See how we going to power up accommodation. I told to adjust the focal length. In the eye, our mechanism going to adjust. See where the lens is present. This lens, this is made up of proteins and fibrous material. No, this is what the lens actually. This lens is, see, it is fixed with like a stand. How outside lens we going to fix with the lens stand? No, like the lens stand, it is act like a ciliary muscle. The ciliary muscles you observe, no, this side and this side. These muscles are fixed tightly with the lens, so that the muscle going to contract or extend, so that the focal length. Suppose you have one ball in your hand, so with the two hands you're going to apply the force. What happens, children? The ball size going to be decreased and it will extend. The length will extend, the thickness. See, initially thickness is like this. You're going to compress. What happens? The length increases, thickness decreases. Like that only our eye also. Okay, eyelids also, it will going to compress. Okay, like this, it will going to apply the force on both ends, it will compress and it will going to elongate also. Okay, compression and elongation taking place. That is what thickness of the lens going to decrease and increases by using ciliary muscles will do that work. Modification of curvature of the some extent. That is what we call. Thin means curvature is more. That means you just understand it is like a some sphere. Okay, if it is thin, curvature is more. If it is thick, curvature will be going to less. Okay, compressed lens will what happen? Compressed of a composed of a fibrous and jelly-like material. It is like a compressed or a fibrous. It is made up of, and you can see also here fibrous and a jelly-like material. This is about the which part of the eye will helpful. And ciliary muscles, what will happen? They will modify the curvature to some extent. Okay, change in curvature leads what? Change focal length. Understood, no children? In the first chapter we understood. If this is a curvature, suppose this is a lens, we're going to understand it is like a, sorry, it is like a some curved surface. Now radius of curvature, see, this is a radius of curvature. If it is a thin lens like this, suppose it's a very very thin lens, what will happen? That time curvature is still bigger. So that time radius of curvature increases. If radius of increases, what happens? The focal length inversely proportional. The focal length changes. If it's a curvature changes, focal length also changes. Okay, children, you know radius of curvature is equals to 2 times of focal length, right? That means if radius is increases, this is also going to increases, directly proportional the factors there. Yeah. Now try to understand this clearly. Just a minute. Yeah. See, ciliary muscles, what will happen? You want to see nearby object, you want to see the objects are very distinctly, means see when ciliary muscles, okay, when ciliary muscles are, yeah, is observe when this lens becomes very thin, okay, that time the focal length, what will happen, it will going to increases, okay, the length we can see here to here, the thickness of the thin lens, the thickness of the lens decreases, that time focal length will increases. We can see distant object clearly, the object is very far, okay, the far object we are going to see very clearly when this focal length will increase. Focal length means up to what extent, okay, this length will going to increases when this becomes very thin. And when the ciliary muscles are contract, this is they are relaxed. Understand this word? They are relaxed. We can able to focal length increases. We can able to see that when this eye lens becomes contract. Okay, that's this the thickness here it is increased. When thickness increases, the focal length will be decreases. That time we can see. Okay, the eye lens curvature lens increases and the eye lens becomes thick and thus its focal length decreases. Focal length here decreases and we can see nearby object. Are you clear, children? The statement when eye lens going to relaxed, okay, that time we can see the far objects. Eye lens going to contract, that time we can see nearby objects. Focal length decreases, no less focal length, nearby objects we can see. Okay, this is regarding the how power of accommodation for eye lens will going to increase or decrease. Okay, suppose you are here, you can see observe easily distant vision. Distant means far object. When we can see ciliary muscle going to relax. When the ciliary muscle relaxed, lens becomes very thin. The relax means the lens will be have enough space. Let the ciliary muscles here and here like windows. They relax means the gap is more, so lens will be fill up to this much area. So it will be very thin. When they're going to contract, what happens? This gap going to decreases. The lens shape will be like bulged or thicker. Okay, this time focal length what happens? Increases or the focal length decreases. We can see here what far object. Okay, here we can see near object. That is what you are given. Okay, ciliary muscles are relaxed, lens becomes thin, focal length increases and enables us to see the distant vision clearly. Okay, this table you just remember. And in close vision, that means near vision, what will happen? Reverse of that. Ciliary muscle is going to contract, lens becomes very thicker. You can see size of the lens is thicker. So that a lens becomes thicker, the focal length decreases and enables us to see the nearby objects. This is what about the close vision and the near vision. And coming to the defects of the eye, okay, we have different defects of the eye is there. One is myopia, nearsightedness, hypermyopia, farsightedness, presbyopia and contrast. These are the different defects of the eye. This will going to understand in the next class. Okay children, next part we will going to understand that. Thanks for watching.